Yeah.
好了吗
Yeah, yeah, yeah.
Okay. Okay. Can you guys hear my voice?
Yes, we
Okay.
could.
So, I'm gonna start our work this week. So, your screen sharing is pause. What reason? Hmm? What?
What
Why?
happened?
I'm not sure. Yeah. Okay. Can you see my screen?
Yeah.
Yep. Okay. So, where should we start? Yeah. Oh, so my part is to do the ductile vector, just like what we did several weeks ago. So, uh, so first I do some like pre-processing, like remove the stop words and URL and also a lot of HTML text and something like that. And then we just do the ductile vector like what it did before. And now in this version, we try three different configurations. We change the vector size to 50, 100, 200, and also the minute count, and other things like that. So it's pretty easy and obvious because we have already done this before. So this is the cluster resort we get, and we can see that we classify it to eight clusters, and this is the result of these three different configurations giving us, and that's probably what I did. And now I'm gonna hand out to Eric to show his word to vect work. Okay, Eric.
You see my screen?
Yeah.
Yeah.
All right. And my part is work to back, and it's not that hard as we imagine. And I'll explain our work to back and plus spinning approach and discuss the results. And we first train work to back model with vector size of 100 and to learn the world level embeddings. And then we apply k-means clustering to group words into semantic bins. And we try the bin size, which is also the same as Dr. Back, 50, 100, and 200. And each document was represented as a normalized frequency distribution over these bins. And this transform variable length text into fixed length document vectors. And we perform document clustering with k equals 8 and evaluate clustering quality using the cosine distance. And here's the output. You can see the word being equals 50 is got the highest score, which is 0.1558. And the higher the bins and the lower the score it gets. So this suggests that increasing the number of bins make document vector more sparse, which weakens cluster cohesion. And in our data set of approximately 5,000 documents, a lower dimensional bin representation captures the dominant optical structure more effectively. And overall, this is our work to vet and binning. And now I'm going to hand it to Justin.
Mhm.
Wait a minute.
Yeah. So my part is to just compare the two results done by Eric and Jeremy. So firstly, is clustering graph. The left side is docq and the right side is virtuac, and it looks like the virtuac has a better clustering result, and we can prove that using our metrics. Uh, so firstly, we use the Seuhatib score, and that one is like measures how similar a document is to its own cluster versus the nearest cluster, and the higher is the better. And we also use the Davis bonding index, and this one is a ratio of within cluster scatter to between cluster separation. As the lower is the better. And we also use the uh, Kalinsky-Harabas index, and it's a ratio of between cluster variance to within cluster variance. And the higher is the better. And we can see like since this one is the higher the better, and this one's the lower the better, and this one's the higher the better, we can see like the Word2Vec is outperformed than the Doc2Vec. Yeah, that's and especially for Word2Vec with 50 binding, it's achieves the best result. So that leads to our conclusion. So we got a Word2Vec plus binding with 50 pins is the optimal. That's pretty much everything for this week. Yeah.